Okay, today I made a low power oscillator. 'Cause while doing more research, watching more videos, playing with sliders, simple wireless system, caught a couple old videos that totally forgot about. One, of course, was Lidmotor's penny oscillator, which is just a pretty awesome little circuit that I never got around to trying to replicate. And then Slider came around and showed his wireless system running from what seemed to me like even less power than Lidmotor's system. And his was just a very simple blocking oscillator using the pancake coil. Whereas Lidmotors seem to require a little bit more components. But at any rate, I never used to think that that was entirely useful until I saw Slider's video where he's actually getting some decent energy, usable energy out of a small capacitor. So I tried to make one of my own, and I ended up using just regular telephone wire. And those have 4 wires inside. So basically what I did was I took 2 of the windings, wound a jewel thief, connected them as a jewel thief circuit, and the other 2 windings I connected in the same way. I basically turned them into a bifilar wrap, and I used both end to end, both polarities as to run my load on, which is just this little LED right here. And so basically I've got a jewel thief circuit, and I've got a flyback winding, which is double the winds, but they're all the same gauge wire. And right now, because I do not have any PNPs, I'm using this little NPNs, I'm using this little PNP transistor, and I actually tried a few different ones and they all worked pretty much the same. But that guy right there, I believe it's a 2N4403. And as my base resistance, I've got 250K audio tapers in series to give me close to 500 ohms adjustability. And then in parallel with that, I've got this little green capacitor, which is labeled 2A473J. But anyway, I really like Lidmotor circuit and Slider's dynamo operated circuit, or he's pretty much just giving his capacitor just a little, giving his dynamo just a little bit of winds, just no effort at all to put enough charge in a small capacitor, like 2200 microfarad I believe, that will power the circuit for 10 minutes or more. That's pretty amazing. So here's my little version that I realized I was actually able to get it to work without any super complicated circuitry. And because this is the only capacitor I have right now that is a decent enough value, this is 6800 microfarad. I wish I had a smaller one, like a 2200. I'm pretty sure I'll find one here coming up. But I've got the Lidmotor radio test here, so I'm going to go ahead and just hook it up to this capacitor that I have. I'm going to turn the radio up. So that's the frequency. You can tell when disconnected, you don't hear it, but it's moving rather fast. It's going a little faster than Lidmotor circuit, so I've got a little adjusting to do. But you see the LED is on. Right now the resistance is set at its highest level, and I do not have any meters that I can honestly trust, but the meters that I have used is telling me that it is pulling as low as 20 microamps. And as I adjust the potentiometers up higher and higher, I can get the light to get its brightest at about roughly 10 milliamps. And then anything beyond pushing a 10 milliamp current, the circuit does not want to operate like it should, or like how you would want it to. So I'm gonna go ahead and play with the potentiometers, and you can hear the frequency go up. So let's play with these pots here, turn it up. And right about now, it's probably at about a few hundred microamps. And if I keep turning it all the way up, you'll see the light get near full brightness, but then it'll drain the cap all the way down. So you heard that I just pumped the rest of the juice out of that cap by turning the resistance all the way down. So what I'm going to do is I'm going to set the tapers all the way back to the highest resistance again. There's no juice left in that cap at the moment, and it will probably slowly rise again. The electrolyte will cause that cap to slowly rise again if I was to take this tiny load off of it. But right now, because that LED is on there and it's slightly conducting but without giving light, I no longer hear my spikes coming through my radio. But even now, it is still oscillating. So what I'm going to do is connect the little dynamo guy up here. I know the light is not very well, so I hook my dynamo to the capacitor. I'm just going to give it a little, there you go. So now the light's back on. Cap's got a little bit of juice in it again, and now you can hear the oscillation. The rain kicks out that spike pretty far too. I mean, we're talking about like 20 microamps. It's so loud I have to turn the volume down on this little guy as low as it'll go. But just that little kick of energy that I put in there, you saw me just give this dynamo just a little flick. I'm not going to touch it again. I'm going to crank this circuit up again just to drain that cap one more time. Can actually squeeze a good amount of little juice out of there, which is pretty amazing, you know, because if you think about it, if I was to connect that LED right to the dynamo and do what I just did, just feed it the rectified AC, it'll get just as bright as you just saw it. But what you just saw with the pulses, the pulse DC made it so much, the light just lasts so much longer. So that's pretty amazing right there. But yeah, very simple circuit. This is just the first rough draft, but it's just telephone wire. It's 50 feet. I got that for $4 at the store. But definitely, you know, the key there is just a super high resistance, and you want to have a capacitor in parallel with that base resistor just to help siphon or cycle that current. But that's pretty much it. And I did notice the LED does make a difference. You want to find a LED that does have a relatively low voltage activation, just so it'll get a little brighter. But that is pretty useful right there. I'm pretty satisfied with that, so might keep playing around with that a little more also.